Ever pondered about the mysteries of the universe? What if you could travel through time using black holes? Welcome to the world of black holes, nature's most intriguing and baffling phenomena. These are not just ordinary objects in the cosmos, but rather cosmic vacuum cleaners swallowing everything in their vicinity, even light itself. And the fascinating part? They might just be our tickets to the past or the future. Now let's break it down a bit. Imagine a star, much like our sun, but much, much larger. When such a star exhausts its nuclear fuel, it collapses under its own gravity, resulting in a supernova explosion. What remains is a core of super-dense matter. If the core is massive enough, it continues to collapse until it forms a single point in space with infinite density, known as a singularity. This is the birth of a black hole. Dare to venture into the unknown? Let's dive into the heart of a black hole. Now, before we start our journey, it's essential to understand what awaits us when we get too close to a black hole. Imagine that we're on a spaceship, heading towards a black hole. As we approach, we encounter what scientists call the event horizon. This is the point of no return, the boundary around the black hole from which nothing, not even light, can escape. It's like the ultimate waterfall, where everything that falls in can never climb back out. But what happens when we cross this event horizon? Well, this is where things get a little stretchy. You see, black holes are incredibly dense, which means their gravitational pull is extraordinarily strong. This intense gravity doesn't pull evenly, however. It tugs much more strongly on the side of our spaceship that's closer to the black hole than it does on the side that's further away. This difference in gravitational pull from one side to the other is what scientists call tidal forces. And when these tidal forces are strong enough, they can cause something called spaghettification. Yes, you heard that right. Spaghettification. Picture a piece of spaghetti. It's long and thin, right? That's exactly what happens to our spaceship, and everything inside it, when it gets too close to a black hole. The extreme tidal forces stretch it into a long, thin strand. So, as we venture closer to the black hole, we'd notice our spaceship stretching and elongating, becoming thinner and thinner. And if we were inside the ship, we'd feel this stretching effect too. Our bodies would become long, thin strands, like pieces of spaghetti. This may sound like something out of a science fiction novel, but it's real science. The physics of black holes is both strange and fascinating, and there's still so much we have yet to understand. So if you plan a trip into a black hole, be prepared for some extreme stretching. Now that we've journeyed into a black hole, what happens to time once we're inside? Imagine you're out in space, floating near a massive black hole. You're wearing the latest in space-time continuum gear, and you've got your trusty cosmic clock in your hand. This clock, just like any other, ticks away the seconds, minutes, and hours. But as you move closer to the black hole, you notice something strange. Your cosmic clock begins to slow down. This isn't a glitch in your gear. It's gravity's effect on time. You see, time and gravity are deeply intertwined in the fabric of our universe. Just like how a heavy ball can make a dent on a rubber sheet, massive objects like planets, stars, and especially black holes warp the space-time around them. This warping effect is what we feel as gravity. And here's the kicker. The stronger the gravity, the slower the time. This is a principle known as time dilation, beautifully predicted by Einstein's theory of relativity. Now let's get back to our black hole journey. As you inch closer to the event horizon, the point of no return, your cosmic clock ticks slower and slower. To an observer far away in space, it would seem as if time has stopped for you. But from your perspective, time is moving just as it always has. So what happens when you cross the event horizon and journey into the black hole? Well, things take a turn for the bizarre. Inside a black hole, the roles of space and time switch. What does this mean? Imagine walking forward. In our everyday life, we can choose to stop, change direction, walk faster or slower. This is how we experience space. But time? It keeps on marching forward, unstoppable and unchangeable. Inside a black hole, it's the opposite. Time becomes like space, something you can move through, and space becomes like time, marching forward, pulling you deeper into the black hole. In this twisted realm, your cosmic clock is still ticking away the seconds, minutes, and hours, but those measurements have lost their usual meaning. It's a mind-boggling concept, isn't it? But that's the nature of black holes. They challenge our understanding, defy our logic, and push the boundaries of what we thought was possible. Inside a black hole, time as we know it takes a back seat. With time behaving so bizarrely inside black holes, could these be our gateway to time travel? Let's delve into this fascinating theory. Black holes, as we know, are regions of space where gravity is so strong that nothing, not even light, can escape their pull. This intense gravitational force warps the fabric of space and time around it, creating a sort of cosmic whirlpool. But what if this whirlpool doesn't lead to an inescapable abyss, but instead, to another point in time or space? Enter the concept of wormholes. Theoretical physicists propose that black holes could act as gateways to these wormholes. Imagine a wormhole as a tunnel with two ends, each end anchored in different points in time and space. Theoretically, if we were to enter a black hole, survive the trip through the wormhole, we would emerge from a white hole at the other end, potentially in a different time or place. White holes, you ask? These are the theoretical opposites of black holes. While nothing can escape a black hole theoretically, nothing can enter a white hole. It's like the exit door of our cosmic tunnel, spewing out whatever made the journey through the wormhole. Now let's get something straight. This is all purely speculative and based on the mathematics of Einstein's theory of relativity. We've yet to observe a wormhole, let alone a white hole. But the math suggests they could exist, and if they do, they could potentially be our ticket to time travel. Imagine this. You're feeling a little adventurous, so you hop into your handy spaceship and fly into a black hole. You brace yourself for the gravitational forces and the pull of the wormhole. You emerge, and voila! You might be in the distant future or perhaps even in the past. However, it's not as simple as it sounds. The journey through a black hole and a wormhole would be fraught with dangers, from the immense gravitational forces to the potential for the wormhole to collapse. Not to mention, we're still not entirely sure what would happen to time as we know it once we're inside a black hole. Would time stop? Would it reverse? It's a mystery that continues to baffle scientists. In the world of theoretical physics, it's an exciting possibility that combines our understanding of gravity, space, and time in a way that could change how we perceive the universe. It's a theory that challenges our understanding of reality and opens up a world of possibilities that were once the realm of science fiction. But for now, it remains a fascinating theory, a tantalizing possibility that keeps scientists and dreamers alike looking up at the night sky in wonder. So there you have it. Black holes, wormholes, white holes, and the tantalizing prospect of time travel. It's a cosmic journey that takes us to the very edge of our scientific understanding and beyond. Just imagine, hopping into a black hole and emerging out in a different time. While black hole time travel sounds exciting, it's not without its challenges. Imagine this, you're a time-traveling astronaut, journeying into a black hole. You aim to return to an earlier time, but here's the catch. The very act of your journey might prevent your own birth. An example of what's known as the grandfather paradox. It's a thought experiment that asks, what if you went back in time and prevented your grandparents from meeting? If they never met, they couldn't have your parent, and subsequently you wouldn't exist. But if you don't exist, then who traveled back in time? This paradox leaves us scratching our heads, but it's not the only challenge. There's also the information paradox. In the quantum world, information cannot be destroyed, but black holes, according to classical physics, destroy everything that crosses their event horizon, including information. So, which is it? Does the information get destroyed, violating quantum mechanics, or does it somehow escape contradicting classical physics? And let's not forget the physical challenges. Even if we could build a spaceship capable of withstanding the immense gravitational pull of a black hole, we'd be dealing with tidal forces powerful enough to stretch anything into a string of atoms, a process pleasantly known as spaghettification. Not exactly a relaxing journey, is it? Furthermore, there's the issue of unpredictability. Black holes are notoriously difficult to study due to their light-swallowing nature. We can't be entirely sure what happens inside them, making the journey a leap into the unknown, possibly a one-way ticket. In the end, the concept of black hole time travel, while intriguing, is laden with paradoxes, uncertainties, and dangers. It's like trying to navigate a maze in the dark, where the walls keep shifting and the exit might not even exist. So even if we could use black holes for time travel, we might end up with more questions than answers. Despite these challenges, the quest for time travel continues. What does the future hold for us? Our journey into the cosmic abyss is far from over, as scientists and researchers around the globe are tirelessly working to peel back the layers of mystery surrounding black holes and time travel. As we stand on the precipice of scientific discovery, it's clear that the future holds a myriad of possibilities. In the realm of time travel research, black holes remain a beacon of hope. Theoretical physicists are delving deeper into the study of these celestial anomalies, striving to understand their complex nature and the potential they hold for bending the fabric of space and time. Advanced technology is playing a crucial role in this pursuit. Cutting-edge telescopes and space probes are giving us unprecedented views into the heart of black holes. This data is being used to refine and test theoretical models, bringing us a step closer to understanding these cosmic enigmas. In the labs, computer simulations are being used to model black holes and their effects on the space-time continuum. These simulations allow scientists to experiment with different scenarios and observe the outcomes in a controlled environment. Moreover, research is also being conducted into the concept of wormholes. These theoretical passages through space-time could potentially provide a shortcut through the universe, making time travel a possibility. Meanwhile, quantum physics is opening up new avenues of exploration. Scientists are investigating the quantum properties of black holes, which could hold the key to reconciling the principles of general relativity with those of quantum mechanics. This reconciliation is crucial for understanding the nature of black holes and their potential for time travel. Yes, there are challenges, but with every challenge comes an opportunity. As we continue to push the boundaries of our understanding, we inch closer to the day when the dream of time travel might become a reality. Who knows, the key to time travel might be closer than we think. So, we've taken a mind-bending journey into black holes and the possibility of time travel. We've delved into the intrigue of these cosmic phenomena, venturing into the unknown, exploring the complexities of the time-space continuum, and posing the question, could black holes be our ticket to the past or future? We've also acknowledged the immense challenges posed by black hole time travel, such as the immense gravitational forces and the enigma of the event horizon. Yet we've also looked ahead, peering into the future of time travel research, a future that holds much promise and infinite possibilities. Through it all, one thing remains clear: the enigmatic nature of black holes and their potential as time travel portals continue to captivate us, inviting us on a journey of cosmic discovery. While we don't have all the answers yet, one thing's for sure: the universe is a fascinating place, full of mysteries waiting to be unraveled. Thanks for watching Time Pilgrimage. Please remember to subscribe, like, and comment.